Hi, today we will learn lens maker's formula. We see many people are wearing glasses because they cannot see object clearly, because they cannot bend light coming from the object, they cannot focus light coming from the object on the retina. So they need assistance of a lens. What is a lens? You have seen people wearing glasses, those are called lenses in their specs. So lenses are transparent material medium bounded by two surfaces. One surface at least out of the two must be spherical. These glasses are called lenses. And a lens maker designs a lens for a defective eye. A lens must have a proper focal length, it must have a proper power, and the focal length of the lens is related to the radii of the two curvatures. A lens has two curvatures, and related to two curvatures they have two radii. So the focal length of the lens is related to the two radii of the two curvatures, and it is also related to refractive index of the material of the lens. And all these focal length, refractive index, the radii of the curvatures are related with a formula that is called lens maker's formula that we are going to derive today. Now you can see that a lens has two refracting surfaces, two spherical surfaces. So we need to learn refraction through these two spherical surfaces. We know that the formula for refraction through a spherical surface is mu2 by v minus mu1 upon u is equal to mu2 minus mu1 upon r. This is the formula which is due to refraction. This formula is used for refraction through a spherical surface. Here your mu1 is refractive index of first medium, mu2 is refractive index of second medium. Here you can see in this refraction, u is the object distance, a distance measured from a point on the surface itself, that is called pole. This distance from pole up to object is called object distance, and the distance from this pole up to a point where image is formed, that distance is called image distance, and the radius of this curvature is called radius of curvature. Now the ray is refracted two times by this lens. This is refraction done by first surface, in which the ray is going from rarer medium to denser medium. So you know that when a ray goes from a rarer medium to denser medium, then the ray bends towards normal, and the normal is along the radius of curvature. So the ray does not go along this direction, ray has bent along this direction, and the angle formed in between the bent ray and the normal ray, this angle is called angle of refraction. All these you know. Now before coming out, the ray undergoes one more refraction by the second surface in the same way. And finally, when you combine the two, you get this diagram. So ray is refracted two times. Firstly at first surface, and then it will refract at the first surface, and then it will refract at the second surface. Two refractions will take place. So let us start with first refraction. So first refraction, your refractive index, first refractive index is mu1 only, And refractive index of second medium, that is glass medium, is your mu2. Now object distance is equal to u and image distance is equal to, in this case I have taken v dash. First image is forming for first refraction. Image is forming at a distance from P1 point, that is pole I am taking. This distance is v dash. So image distance is taken as v dash. Now we should apply all this data in our formula for refraction, that is mu2 by v minus mu1 upon u is equal to mu2 minus mu1 upon r. So therefore it becomes equal to mu2 upon v dash minus mu1 upon u is equal to mu2 minus mu1 upon, and first radius, this is your first radius, I have taken r1. This has become mu2 minus mu1 upon r1. This is your first equation for the first refraction. Now we will consider the second refraction at second surface. At second surface, there is second refraction, and for second refraction your first refractive index 1 for second refraction you find here at this surface. Now the first medium is glass medium and the first refractive index will be mu2 only. So first refractive index is mu2, and similarly your second refractive index is mu1. Your object distance is equal to, in this equation you can see this first image formed due to first refraction. This image will be served as object for your second refraction. This is your virtual object for second refraction, and object distance in the second refraction is your v dash. So for second refraction, object distance is your v dash, and finally image distance is the final image distance, this one. Here final image distance, that is your v only. Now let us put all these values in your formula of refraction through your spherical surface. Now since mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 upon r, therefore mu2 here, mu2 is actually mu1 and your v is your v, okay, minus mu1. What is mu1? Mu1 actually is your mu2 upon what is u? V dash, and this is your, just take in this sequence this is your mu1 minus mu2 upon, and the second radius of curvature is r2. So let me make a change so that this term comes equal to this term. I am taking a minus sign common from here, minus mu2 minus mu1 upon r2, and this is your equal to mu1 by v minus mu2 by v dash, equation 2. So when you add equation 1 and equation 2, you will find that this common term, this is your common term, this will be cancelled. So let me first write the equation 1 just near to equation 2, this is your mu2 upon v dash minus mu1 upon u is equal to mu2 minus mu1 upon r1. This is your equation 1. So let me add the two equations so that this common term can be cancelled. So on adding, you get that mu1 by v minus mu1 by u is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. I have not used the sign convention because while deriving the formula of refraction through a spherical surface, we had considered the sign convention. So we simply use the two formula and we add the two formula. Now after getting this formula, after this, when we apply this formula, now we will be using the sign convention while putting the value of u, value of v, by putting the value of r or anything. Now we will be putting the sign convention. So if when object distance, object is at infinity, then what will happen? U will be your minus infinity. I have used here sign convention because object is on left hand side, it is at infinity, so I have taken here minus sign, and in this case V will be equal to F only. You know that in a convex lens, when object is at infinity, V is at focus, and this focus is positive because parallel ray always meet just after the lens. So focus is your positive. So let me put the value of u and v in this equation A. Now in equation A, one by f comes equal to your, I am taking, let me do one more step. A step is left over here. So let me take mu1 common from here. 1 upon v minus 1 upon u is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Now you will be using these values of u and v to get 1 by f is equal to, and mu2 by mu1 you can write mu2 1. Relative refractive index of medium 2 with respect to that of medium 1, and this minus 1 into 1 by r1 minus 1 by r2. This is your called lens maker's formula. Here f is related to the radii of curvatures of a convex lens or any lens, and it is related to relative refractive index of the medium. This is called lens maker's formula. So now when you use this formula, you will be using sign convention for all these distances, for r, for r2, for focal length. So let us do one question related to that. The radii of curvature of faces of a double convex lens are 10 centimeter. You have one surface. So first refraction will be taken place at first surface, and therefore you have this first radius. You will find that the first radius when measured from optical center, because here one more thing I would like to suggest you. One more thing. The two distances I have measured from point P1 and point P2. They are two separate distances. So for thin lenses, the two distances, the 2 points can be considered as a single point, that is point P which is at the center of the lens itself. And that point is called actually, this point P is actually called optical center O. And all the distances are measured from optical center in case of a lens. So now in this question, when ray of light is incident in this direction, then you will find that this first radius is measured in the direction of incident ray. So this first radius should be taken as positive. This would be your plus 10 centimeter. But second radius, here you can see that we are using sign convention now. Second radius is measured from optical center up to center of curvature of first surface in a direction just opposite to the direction of incident ray, and this is taken as negative, minus 15 centimeter. Your focus is taken as focus of a convex lens is always positive. I have just told you, and this should be equal to plus 12 centimeter. So now we have to find what is the refractive index of the glass. We have to find refractive index. So now let us write the equation of formula of lens maker's formula. Since 1 by f is equal to mu2 1 minus 1 into 1 by r1 minus 1 by r2. So let me put all the values. 1 by 12, okay, and this is your mu2 1 minus 1, 1 by 10 minus 1 by minus 15. So now we will be taking LCM of this. (150), this is your 15 minus plus 10. So therefore 1 by 12 comes equal to mu2 1 minus 1 into 25 by 150, and this goes 6 times, and 6 here 12 goes 2 times. Therefore mu2 1 minus 1 is equal to half, means 0.5, and therefore mu2 1 is equal to 1 plus 0.5 is equal to 1.5. So you saw that while using the lens maker's formula, we will be using sign convention. Let me take one more example. A biconvex lens has a focal length. You know that in a convex lens, focal length is always positive. So it is equal to 2 by 3 times of the radius of curvature. Let the radius of curvature is r only. Let radius of curvature is equal to r. Therefore, r1 becomes equal to r. r1 is your positive as before, and because it is along the direction in which the ray is falling, it is measured along that direction from optical center, and r2 comes equal to minus r. Now you have to find refractive index. So let us put all values in lens maker's formula. Since 1 by f is equal to mu2 1 minus 1 into 1 by r1 minus 1 by r2. It implies that 3 by 2r. I have taken 2r by 3 in place of focus. So it becomes equal to mu2 1 minus 1 into 1 by r minus of 1 by minus r. So this becomes equal to mu2 1 minus 1 into 1 by r minus plus 1 by r. This becomes equal to 2 upon r. R and r is cancelled. So mu2 1 minus 1 is equal to 3 upon 4. And 3 upon 4 is 0.75. Therefore, mu2 1 is equal to 0.75 plus 1 and this is equal to your 1.75. So I conclude today